Alright, so did anybody get a chance to see what all we are going to cover today? Let me read it for you guys. Okay. Hey Chris.
Okay.
So we are going to cover polynomials, the basic introduction of polynomials, the standard form of polynomials, what is polynomial versus what is not, then what are different elements of a polynomial, and then evaluating and doing some basic operation with polynomials. So that will actually set us for going deeper into polynomials in the subsequent classes. So here's your WhatsApp. So let me do a quick roll call and then we'll see who all are here. So we have Dev, Chris, Neil, Praneeth, Rehan, Sara, Shravya, Sivatsav, Vihan and Vishal. So this is the first class for Vishal. Vishal was in another group and he has impressed me enough to be part of this group. So that is how Vishal is with us in this group. Alright, so we will start with the polynomials. Are you all set? Any questions you have before I do so, before I start? Okay. And stay safe in this extreme cold, unlike me. Alright, so when you say polynomials, can anybody give me a very simple definition of what is exactly called a polynomial? What do we mean by that? A very basic definition.
Is it multiple terms?
Multiple terms. Okay. Anything else? Yes, Vishal?
A expression that has more than two algebraic terms.
Okay. That's another definition. Anybody else? Okay. So let's look at it. So first thing is we talk about polynomials, monomials, all that with respect to primarily expressions, sometimes equations. So let's look at an expression. When you say an expression, what do we mean? Let's say 2x squared plus 4x minus 7. This is an expression. Why? Because it is not an equation, it's an expression. Because you have to have an equal to sign for somebody to be called an equation. Since we don't have an equal to sign, it's just an expression. Anything that results into something which has an equal to, saying okay, something plus something minus something into something equals something. And true. So when you have multiple things added or subtracted, multiplied, or some operations with them without any outcome to it, that is called an expression. So when we talk about polynomial, we will talk with respect to expression to begin with. Now, if you look at, before you go to any expression for that matter, let's break it down. If you look at this, I have two things here, poly and nomials. Poly is a Greek word, this is a Latin word. Yeah? So, poly means many and nomial stands for name in Latin. I hope I'm saying it right, or at least I'm pronouncing it right. So, polynomial stands for many names. And in mathematical world, we'll say many terms. Now you'll say, what is a term? So everything here that you see, everything that has a unique identity or separated by an operation is called a term. So if you look at this expression, 2x squared plus 4x minus 7, there are three terms here. One is this 2x squared, second one is plus 4x, and third one is minus 7. These are three terms. So when you have an expression which has many terms, that is what is called polynomial. Are you guys all with me so far? Alright, so kids who have joined late, like Anshu or Sarah, are you guys with me so far? Are you able to follow? Okay. So now, what is called a many? Anything which is more than one. If I have one, that is one. You would have heard the term called monorail that runs on one track. Mono stands for one and poly stands for many. So you will very frequently come across two terms, monomial and polynomial. Mono is for one, poly is for many. So if you see something like 4x squared or 7x to the power 9, these are monomial expressions. If you add 4x squared minus 6x plus x to the 8x to the power 7 minus 4, this is a polynomial because you have multiple terms. Now let's double click on these. So everything that you see here is a term. 4x squared is a term. Minus 6x is a term. This is a term. This is a term. Now, if you look at every variable, a term with a variable, this part is just the variable, and this is called the degree or the exponent. This is the coefficient. So if you look at the first term, it has x as a variable, 2 as a degree, and 4 as a coefficient. Similarly, if you look at this term, 8x to the power 7, x is your variable, 8 is your coefficient, and then 7 is the degree or the exponent. So if you look at one polynomial, let's say 2x cubed minus 4x squared plus 6, this is an expression. What is the degree of this polynomial? Any guesses? 3. So you always look at the highest degree of all the terms. If you look at one expression, you always look at what is the maximum exponent of the variable or maximum degree of the variable, maximum degree of any of the terms. So if you look at this expression in entirety, you are essentially talking about this is the maximum exponent or power for this expression. That's why the degree is 3. Now, one trick question, you guys can call it a very stupid question also. Can somebody tell me what is the difference between these two with respect to polynomial? You guys can see the board, right? Okay. So can somebody tell me what is the difference between these two? Yeah, Vishal.
I think the first one is like it had the power. The first one had the power of 2, while the second one had the power of -2, which makes it like a fraction. Like it makes it like a real number instead of like in power. I think.
Not convincing yet. Let's see if somebody has any other point of view. Yes, Dave.
I think 4x2 we know is concave up because it's positive. And I think the 4x to the power of -2 would be concave down, like going towards 0.
That's an observation, but still not convincing. Anybody else? Chris, Dave, Sivatsav, Vihan, Vishal. Vishal has told. Praneeth, Anshu. Okay. Now, first thing to remember, if you have a polynomial, this is a polynomial, This is also looking like a polynomial. Okay. But I would say this is not a polynomial. Why? Because by definition, any polynomial means an expression which has multiple terms and has exponents or degree greater than or equal to 0. Okay. So if ever your exponent is less than 0, that gets disqualified for being called a polynomial. Okay. So if you ever come across a scenario where you have a polynomial-like thing, it could be a trick question, right? Any of the expression if you have which has power in negative, that means it comes as 4 to the power 4 like this. Any negative power to the variable or any negative degree to any of the exponents, any negative degree to any of the terms gets it disqualified from being called a polynomial. Does it make sense so far? Does it sound like something that we learned today? Because mostly I teach the boring stuff, things that is already taught, but this is something new. Okay. And I'll be honest to you guys, when I was kind of revising the concepts, then I found this as a very important part, which is a very basic concept, but we tend to oversee some of the important basic elements of the definition. Okay. So this much is clear to everybody? Alright. So we looked at what is the definition of polynomial, what is the breakdown, then what are the different parts of a polynomial. If I say 4 plus 8, is it a polynomial? I'm sorry?
No.
Okay. Can I understand the reasoning behind? Yeah, Dev.
Because for it to be a polynomial, there needs to be 2 terms, and this doesn't have 2 different terms.
Okay. How about you, Vishal? Any different point of view?
I was about to say the same thing.
Okay. Praneeth, want to add something?
The 2 terms in this can be added to create 1 term, so it's not simplified.
Right. Yeah. So basically, look, if you just go by the definition, it is a polynomial because there are 2 terms. But eventually, what happens is, in a polynomial, you will see two or more unique or 2 or more different terms. Here, these 2 are similar terms. This can be added together. If you have 4x minus 9, you cannot, by no means you can add them together unless you evaluate. So there is no mathematical ability that we all have to add 4x and 9 together unless we have a constant value for x. But in this case, these 2 gets added. So this one will never qualify for being a polynomial. Though by definition you can say there are 2 terms, but actually that gets added. These are not two unique terms. These are 2 not different terms. So that's why these are this is not a polynomial and this one is polynomial. And it's always understood or assumed that if you have a polynomial, let's look at 4x cube plus 2x minus 7. It's always assumed that every term has 3 parts to it. One is a variable, second one is the degree, and third one is the coefficient. Every term. Okay? So same thing here. This is your variable, degree is 1, and this is your coefficient. This is your coefficient, and you can always say this. So your degree is 0, and your coefficient. Or I mean, you can say that this is your coefficient basically. This whole thing is your coefficient. This one is your coefficient. So every polynomial that you look at, it comprises of multiple terms, and every term comprises of 3 things: the coefficient, the variable, and the degree. This part is clear? Now, what do we mean by a standard form of a polynomial? Okay. Yes. Yes, we
Where
have.
like all the terms with their highest degrees are first, and then they descend
In the descending order, basically, right? So if I look at a polynomial, has no boundaries, right? I mean, it can have as much degree as you can think of. I can have a polynomial which says, I don't know why I'm starting with 4 always, but this minus 2x to the power 99 plus 7x to the power 44, and I can simply go on. Any expression which has more than one term is a polynomial, and can have as many terms you can think of. And then I say, so if you look at this polynomial versus, I don't know why I'm starting with 4 today always, but that's okay. Let's say this. If I look at this polynomial versus this polynomial, this is not in the standard form, because if you see the degree is fluctuating. 100, the first one degree is 100, 99, then went to 44, then again went to 96. So if the degree of the polynomial, degree of the terms is not in the descending order, that is a non-standard form. For any polynomial to have or to be in a standard form, it has to have the degree of the terms in the descending order when you read from left to right. Okay. Again, these are some basic definitions, but this will just help us be much more thorough or clear with the solution of these problems when we go to the next step, or the remaining concepts of the. Okay. All right. Alright, so let's go to the next topic that we have here. Any doubts, any confusion so far, okay? Let me know. Any doubts or confusion so far? Okay, let me go to the next element. So we have looked at what is standard form of polynomial, what are the different elements of polynomial. Now comes evaluating a polynomial. So if I say evaluate one polynomial, not for this time, 13x cube plus 2x square minus 17x plus 18. Evaluate this for x equal to minus 6. Does everyone know how to do it? Let's do it. I'm just trying to be a little lazy today so that I talk a little less, okay? Because my throat might give up any time. So I'll make you guys practice a bit. So I'm saying evaluate this expression 13x cube plus 2x square minus 17x plus 18 for x equal to minus 6. I hope everybody is trying to solve it real quick. And again, this has more to do with the practice. I mean, more you practice, more comfortable you will get. So no harm in getting your hands dirty. Yes, Chris.
Sir, can you repeat the question? What are we trying to find?
So I have an expression 13x cubed plus 2x squared minus 17x plus 18. I want you guys to evaluate this for x equal to minus 6.
Okay, thank you.
Yeah, we have to be.
I got minus 2616.
Minus 2616. Okay. Let's see what everybody else gets.
I got the same thing.
Okay. Okay. Anybody who is not able to solve this? I mean, it's okay. I mean, there could be problems that I'm not able to solve. That's fine. I mean, and there'll be times when I will reach out to you guys, say, okay, fine, this particular problem I'm not able to solve. Can anybody in the class solve it? Okay, that could be a possibility as well, right? I'm hoping for a day when you guys will learn or know things more than I do. Any other answer? Yes, Chris.
Yeah, I got the same thing.
You got the same thing. So I heard three answers from three of you. I'm assuming everybody has gotten the same thing. It's very simple, nothing complicated about it. When you are being asked to evaluate something for the given value of x, you will just substitute that with this, and that's what we'll do. So 6 times 6 times 6 is 216. Yeah. 13 into minus 206 plus this is 6 squares of 36 times 2 is 76. 36 times 2 is 72 minus 17 times 6 is plus 1 102 plus 18. So this becomes whatever 13 6 8 36 plus 7. You guys got 2616, right?
Yeah, we got negative. I got negative 2616.
Now, don't tell me I have forgotten basic calculation now. Minus 6 cube is minus 216, and then 6 minus 6 gives me a 36 times 2 72. 76 is 102 and 18. So I have got 13 times 216. So 13 6 is 78. So 8 is here, 7 carry forward. 13 is 13 plus 7 20. 2 carry forward. 13 2 is 26 plus. Okay, yeah. So yeah. So minus 2808 plus this is 72 plus 18 is 90 plus 102. So 192. Yeah, I think you guys are right. I made a small mistake here, right? So that is why it is very important for all of us, right? I mean, I failing is not a big deal. I can afford to fail, but you guys cannot go wrong. So yeah, keep practicing. Easy, difficult, all kinds of sums that you come across. Because if you go wrong here, you might pick up a wrong answer, and that will get you away from scoring a perfect thing in your maths in SAT. Okay. So again, my goal is to make sure that each one of you get a perfect or near perfect score in maths in SAT. Okay, that's the goal we are working towards. If you just want to get what you wanted to get before, then probably you're in the wrong place. The goal is to get a near perfect score. I mean, I know 800 will sound way too tough, but 780 doesn't do any harm as well. Anyways, so let's go to the next topic. So we talked about parts of polynomial exponents, evaluating polynomials, simplifying polynomials, and basic operations. So if we if we have to simplify a polynomial, what does it mean? So again, the topics that we are going to cover today, this might sound very easy ones, knowing the level that you guys have got into, but look at it. It's just about being more careful with what you do. Let's say 4x cubed plus 6x squared minus x squared plus 2x cubed plus x4 minus 16x plus 18x6 minus 12 plus 18 minus 2x squared. If you have an expression like this, 4x cubed plus 6x squared minus x squared plus 2x cubed plus x to the power 4 minus 16x plus 18x to the power 6 minus 12 plus 18 plus 2x squared. I know this might look like a very funny question for you all, but then this is essentially what it is when it comes to simplifying a polynomial. You have an expression where you have a lot of terms. If you just say, okay, how many terms do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. But then there are similar terms, and that's the underlying premise of a polynomial, where it says that you can only deal with similar terms and you can combine them or do operations with them to simplify an expression. Do you guys want to give it a shot? Is everybody able to see the question on the board? Okay. I would want you guys to simplify this polynomial and give me something easier that I can look at.
Sir, what's the last number?
It's 2x squared minus 2x squared. Is that clear, Sarah?
Yes, sir. Thank you.
Okay. I see some students not in the class. I'm just wondering if anybody is facing any power outage or any other infrastructure issue due to this storm, at least in the DFW area or Chicago area. Yep. Yeah, Vishal.
I got 18x to the power of 6 plus x to the power of 4 plus 6x to the power of 3 minus 3x to the power of 2 minus 16x x 16x plus 6.
Okay. Yeah, so I will not wait for everybody else to finish it, because this is not a complex problem where I would want you guys to get stressed out. What we have to understand from this one is, we have to always look at terms which are similar, where you can deal with them. Like I always give a very lame example where I say, you cannot add apples to bananas. If you have 5 apples and 3 bananas, you cannot say 8 apples or 8 bananas. It will remain as 5 apples and 3 bananas always. So likewise, when you look at the terms here, you can clearly say that when your variable and the exponent makes it a unique term, that decides which one it can get added with. When you have an x square can only be added or subtracted from an x square term, a term which has x square into it, only x square. You cannot add the 6x square with 2x cube. So treat them as separate fruits, separate animals, separate people, separate grades, whatever you call it. But then you have to always look at term which has same variable and same exponent, and that is what you can deal with together. So if you look at this one, what is the highest degree of this exponent? Sorry. What is the highest degree of this polynomial? So the term with the highest degree is this one, 18x to the power 6. And is there anything that is matching with this guy? There is no x to the power 6. So that guy remains as an independent entity. It's 18x to the power 6. So this one is done. So this one is done. Let's go to next one. Then what is the next highest degree you see as x to the power 4? And does it have any companion or friend? We don't see any other term with x to the power 4. So this guy remains as another independent identity. So this one is also done. Keep marking it. And again, this might look dirty, clumsy, but then when you are doing the rough work, don't rely on your eyes. Okay? Keep making sure that you are marking things. Now comes the next term, x to the power 4. What is the next highest degree? We see x to the power 3. So this one and this one. Nothing else. So 4x cube and 2x cube. So 4 bananas and 2 bananas makes it 6 bananas. So this one is also done. Keep marking it. Then you are left with x to the power 2. How many terms you have with x to the power 2? This one and this one. And this is negative and this one is also negative. So that makes it minus 3x squared. So minus x squared minus 2x squared. You see minus 3x squared. So this one is also done. This one is also done. So even if you don't like my style, but trust me, this might not look like a very intelligent approach, but math is all about how you do your rough work. How do you keep track of what you have done? When you're dealing with such a problem where you have too many terms to deal with, it's always better to avoid trusting your... Okay, see, one thing I missed. I counted this one and I counted this one. What I missed was this one. So 6x squared minus x squared minus 2x squared. So this is positive 6x squared minus 3x squared. So 6x squared minus 3x squared, that makes it plus 3x squared, which you might want to validate. And again, it's not because of any gap with respect to how we understand things. It is primarily because of an oversight. So like I had an oversight, I missed this one. So now everything is covered. What is remaining is minus 12 and plus 18. That makes it plus 6. And then this 16x. So this is what we have written in the standard form now. If you look at all the terms, this is 6, 4, 3, 2, 1 and 0. So this is the decreasing order of the degree. So this is the standard form. And the only takeaway for us was, there is no problem that is difficult. Sometimes we make it difficult by having a small glitch in our oversight, like what I was doing. I had overlooked this one, and that is why my answer was minus 3x squared. When I take that into account as well, everything falls in place. And trust me, in the exam you will be given both the options, this one and one with minus 3x squared. One small oversight, 800 comes down to 780 or 790 maybe. Yeah. Now I'm giving you guys, I'm not trying to create the pressure of getting 800. It's not about 800. It's just about doing your sums in the most time optimal way. That's it. Yeah. And never trust yourself. Never trust your teacher as well. Even if I'm saying this is the answer, you review your solution by yourself. Just spend, it will not take more than 10 seconds. Whatever you have done, you might have taken 1 minute to solve it. and it takes another 10 seconds to review it. Yeah, so get into the habit of review, you will see it makes a huge difference. Yeah, so Vihan, Shravya, Sarah, Neil, Dave, Chris, everybody with me? Right? Alright. So I never promised you guys that I'll teach you guys most complicated stuff every day. Some days I will teach you simple stuff also, which makes a lot of difference. Yeah. So these are some simple tricks. So if you want to use some mathematical approach towards how you go about taking a test, right? It's a 3-step thing. When you go into examination hall, the first thing you should do is look at the question paper and see if you're able to see all the questions or glance through the questions real quick. Let's say the allotted time is 3 hours for a test. It is worth spending initial 5 minutes, 5 or 7 minutes, to glance through all the questions quickly and mark the ones that you believe would take longer time for you or seems a little complicated. You're not trying to solve any of the problems. Just by glancing through it, you would be able to identify those 4, 5, 6 problems that might take you longer time. And you just mark them. Okay, question, you can write it on your notebook. Okay, say, okay, fine. Question number 6, 8, 10, 12, and 18. These might take more time. I will come back to these questions later. Let me finish other ones, which seems much easier than this. Then I'll come to this. So these 5, 7 minutes that you invested will help you save at least 30 minutes of your time towards that. Let's say you start from 1 and going in a sequential manner. When you got stuck at number 6, you thought it will take 2 minutes, it took you 12 minutes, and that creates extra pressure on you. So you don't want to deal with the problems, at least the tricky ones, in the beginning. Keep it parked for a later part of time. You certainly don't want to, let's say if you have 40 questions to solve, you don't want to waste your time on every question. You have like 3 hours is 180 minutes. So you have 4.5 minutes for every problem. If one question takes you 20 minutes, that creates pressure on you for remaining questions to solve. So keep these guys parked, and the easy ones you can probably skim through quickly and finish it, and then you come back to these questions, say, okay, fine, now I have enough time, I've saved time for you guys, let me deal with you one by one. Okay, so that is one part of the review that you would want to do in the beginning. And second part of the review is that is what you do towards the end. So if you have 3 hours for the exam, keep your 10 minutes. And that 10 minutes you're actually saving by doing all this thing towards the end, to quickly glance through all your answers and look at one more time to see if you have missed something or overlooked something. Because this will, even if you identify 3 problems that you would have gone otherwise wrong, that is going to bump up your score. So these are the smart investment that you have to do. And you will think that, okay, sir, you are saying that I should waste my 5-7 minutes in the beginning and 10 minutes in the end. So essentially I'm talking about 15 minutes or 18 minutes to waste. It's actually an investment. Okay, so, and I would say, I mean, again, this might sound like a theory, but all of you, we are doing test every month once, right? I would encourage you guys to practice it that way. Like last month when we did the test, some of you were not having enough time to finish all the sums, all the questions, right? Apply this technique and see if this time you got a little better. Last time, let's say you could not solve 5 problems. This time, if you come down to a point where you're not able to solve only 2 problems, 3 is your bonus. Yeah? I mean, not everybody gets 800. I'll be more than happy if any of you get 790 also, right? So would your parents. So what I'm saying is, you have to start applying those strategies. See, 80% of the topics that I teach in the class, you guys already know about it. Just that you have not been doing it every day. So when we come across those topics in the class, you will find that, okay, there's something that you knew, something that you had kind of seen in the past, but you don't remember that. So it becomes a learning. But then it's just not about learning it. You'll learn it today, and again you come back to the topic after 4 months. You'll again recall it. You'll be able to solve it. But then what matters is your strategy. Strategy is the key. Okay. I mean, I was hoping the same thing happens when my daughter was going to KD and all. I was hoping that they do those kind of workshops, but I don't think they do it either. I'm not sure about Kumon. Anybody who has been attending Kumon classes, they can probably tell me if they talk about strategy or not. But that is what differentiates. Everybody is equally good. There's a difference between the student who gets 780 versus 720. The only difference is strategy. Otherwise, I can safely assume that both the students have the same level of skill or knowledge when it comes to knowing the concepts. It's just the strategy which makes a huge difference. Okay. Was that an overdose? It's okay, you can tell me. You said this was an extra information not needed.
But it was helpful.
I'm sorry, Vira?
It was helpful.
It was helpful, yeah. So we will start. See, again, I'm not saying that I have any magic wand with me. What I'm saying is, we'll apply one strategy and see if that makes a difference, a positive difference. And then, if it works, wonderful. Let's say that strategy works for, let's say, 80% of you. Then that is the solution then. If it doesn't work, let's say it works only for 10% of you and rest 90% of the class feels that, oh, that was a waste of time. It's okay, there's no damage done. Since we are doing the test every month once, even if you guys get a less score or no miss questions, that's okay. It's not doing any harm. But you'll be better prepared. You'll have a better informed ability to make decision when you go for SAT exam. Say, okay, these three strategies had worked, these two had not worked. So I will only apply the ones that actually worked for me in the past. Yeah. And any of you who are aware of any particular strategy, anything that you have learned, I would suggest, please feel free to share this in the class. Okay, in this group. Many of you are in the part of the WhatsApp group, so you can share your strategies, because two advantages. Okay, when you share it, you kind of end up revising it for yourself, so that will anyways get you a better score, and others are also going to get benefited by that. At least we'll be able to assess whether those strategies are effective ones or not. So when you come across some interesting strategy, I would suggest or encourage you guys to share that in the group. We have to make sure that each one of us get benefited by each other. And trust me, Dave's score is not going to hurt Chris. Chris's score is not going to hurt Anshu either. Yeah. If all of you get 790, why not? Yeah. All right. So let's move on. The last part is something similar to what we have done. Okay. So we were talking about simplification of a polynomial. Next thing is doing operations with polynomial. So when you say operations, operation essentially means four things: adding, subtracting, multiplying, dividing. Right? So if I have a polynomial, let's say 2x squared minus 4x minus 16, this is one polynomial, and then I have another polynomial which is x cubed minus 16x squared plus 8, and I have a third polynomial which is x to the power 2 minus x. So there are three polynomials. If I have to add them all, do you think we need to practice that? It's simple, right? The thumb rule is you'll not add apples to bananas. As simple as that. That might look like a wrong or very stupid analogy, but that's how it is. You will not or never dare to add x cubed with x squared. These two are different things. These two are from two different races, I would say. I mean, again, I don't want to go there, but yeah, these are totally different entities. I can never add a 4x with an 8. These two belong to two different communities, two different types of terms we are dealing with. Okay, so when it comes to adding them, you know that okay, which one you'll add with whom, and that gives you a solution. When it comes to subtracting, let's say if I say subtract this one, this minus this. I know it might sound like a very easy problem, but there could be a scope for mistake. Let's see if we come across a scenario when we end up having a mistake. Can you subtract x cubed minus 16x squared plus 8 from 2x squared minus 4x minus 16? Can I assume everybody is trying to do it? Okay. Anshu is always the first one to raise the hand so that I don't bug her. Today I cannot bother you guys much because of my funny throat. Yes, Vihan. Yeah, tell me, Vihan.
I got minus x cubed plus 18x squared minus 4x.
Say that again. 8x cubed minus x cubed plus
18x squared.
18x squared. Okay.
Minus 4x minus 24.
Okay. I'm not expecting you guys to make a mistake with this one, but my own unfortunate problem is I don't trust anybody when it comes to solving math, and that's not because I have any personality flaw. It's a message that I'm passing on to you guys, saying that never trust anybody. Okay, even if you are confident that Vihan never goes wrong, you solve your problem by yourself. Okay. All right. So if I'm doing it, say this is what I'll do, right? So this is what Vihan would have done. Everybody can probably pay attention to this one. It's not a difficult one, but still, just a word of caution. So 2x squared remains 2x squared, minus 4x remains 4x, minus 16, and then we break this bracket, minus x cubed, minus into minus becomes plus, 16x squared, minus into plus becomes minus 8. So I have deleted your answer, Vihan, but you can verify it once I finish it. So this is x cube. See, one small mistake. So minus x cube. This is the highest degree. I'll write first. Then I'll look at x square elements. So 2x squared plus 16x squared makes it 18x squared. And then this is done, this is done, this is done. What we are left with? Minus 4x. So minus 4x, this is also done. Then minus 16 minus 8 becomes minus 24. Yeah. So this was more of an easy problem, but so far we have dealt with the basic constructs of polynomial, where we learned the basic definition, what is a polynomial versus what is not. And the most important learning was that if you have any polynomial which has a degree, which has a term with a negative exponent or negative degree, that is not a polynomial. You cannot have a polynomial which has a negative degree, a negative power. Yeah. So, and then we learned about the different elements of it. What is the coefficient? What is the variable? What is the degree of a polynomial? We look at all the terms together, and then how do you simplify or do basic operation of addition and subtraction with polynomials. We have 10 more minutes, and again the extension of the same thing would be, let's say if you talk about multiplying polynomials, if I have, let's say, x squared minus 4x plus 2, this is to be multiplied by x squared minus 4. You know how to break the bracket open, and that is what you will do. If somebody says divided by x plus 2 or x minus 2, then we have learned how do we solve a quadratic equation by factorizing it. Here we have a quadratic equation, so we can look at factorizing it and then see if we can divide that. So net, what we have learned with quadratic equation or other concept that we know with basic algebra, we can apply that for doing all the possible operations with polynomials. So we'll do a double click on this for the remaining topics in the class tomorrow. So far, whatever we have learned, anything that was not understood or difficult to follow, I would want to hear that from you guys. Was there anything that was not easy to follow? Or anything that I made purposefully complicated for you guys? I think this topic was not powerful enough to even give me the opportunity to make it complicated for you guys. This was an easy one so far, whatever we have covered. But what we are going to cover in the subsequent classes, that is where you will see some interesting elements to it. So hold your horses till we go into the interesting details of polynomials. All right. So I'll let you guys go 10 minutes early, just to make sure that I treat my throat one more time before the younger ones join the class. Yeah, and make sure that you guys stay warm, stay safe, because it's not fun with so much of snow outside. Yeah, we had.
That was fast.
Okay, that's a problem. Yeah, I mean, people who are living in DFW area, we are not used to seeing a lot of snow. And when it snows, everything comes to a standstill. So that's what we are experiencing right now, where we cannot even move out of the house. All right. See you guys tomorrow same time.
Nice, sir.
Bye bye.
Bye.
Bye bye. Bye bye.
Thanks.
Bye bye. Bye bye.
Bye, sir.
Bye bye. Take care.